Good morning, students. Today we will study second chapter from NCERT syllabus, that is chapter number 2, acid, bases and the salt. In this chapter, first we will study these indicators. So what are these indicators? Indicator is a substance. Indicator is a substance which indicate the acidic or basic nature of solution by color change. That is called as an indicator. Now, there are different types of indicators. Some common types of indicators are: one is a natural indicators. These are obtained from natural sources, therefore called as a natural indicators. These are litmus, turmeric, red cabbage, China rose are some common natural indicators used widely to show acidic and basic character of substances. Now, one by one, we will study in detail. Now, what is this litmus? Litmus is obtained from lichen. Lichen is one of the plant, that is algae type, from which this litmus is obtained. The solution of litmus is purple in color, and litmus paper, it comes in two colors, that is a blue and red. So in acid, blue litmus paper turns red, and in base, red litmus paper turns blue. So that is about the litmus. Now turmeric. Turmeric is another natural indicator. Turmeric is yellow in color. Turmeric solution or the paper turns reddish brown in base, and turmeric does not change color with acid. Means turmeric indicator is used for testing base. Then red cabbage. The juice of red cabbage is originally purple in color. The juice of red cabbage turns reddish brown with acid and turns greenish with base. So red cabbage indicator used for testing acid as well as base. Then indicator are second type of indicators are olfactory indicators. What is this olfactory indicator? So substance which change their smell when mixed with acid or base, these are called as a olfactory indicators. For example, onion and vanilla. These are the examples of olfactory indicators. First is onion. The paste or the juice of onion loses its smell when added to base. So in the presence of base, the smell of onion disappears, and its smell does not change in acid. So it is used for testing the base or the basic substances. Second is vanilla. The smell of vanilla, it disappears, it vanish with base, but no smell vanish with acid. So it is also indicator, olfactory indicator used for testing bases. So olfactory indicators are used to ensure the precipitation. It is the participation of visually impaired students. So remember this use. Olfactory indicators are used to ensure this participation of visually impaired students in the laboratory. Then synthetic indicator. Third type of indicators are synthetic indicators. They are synthesized in the laboratory, therefore called as a synthetic indicators. Examples are phenolphthalein, methyl orange. These are commonly used synthetic indicators in laboratory. So first is a phenolphthalein. It is a colorless liquid. It remains colorless with acid but changes. It turns into pink color with base. So in the presence of base, phenolphthalein turns pink in color, but acid do not changes its color. Then methyl orange, it is a second synthetic indicator. It is originally orange in color. It turns red in acid and yellow in base. So these are the three different types of indicators. Now, in the tabular form, we will study all these indicators, their names, their original color, in acid, what change take place, and in the presence of base, which change take place, this we will study. Now, first is, it is a red litmus. Red litmus, its original color is red. There is a no change color of this indicator in acid, but it turns blue in color in base. So that is the first indicator. Then second indicator is a blue litmus. So blue litmus, its color is blue. It turns red in acid and there is a no change in base. Third type of indicator is third indicator is a turmeric. It is a yellow in color. Original color is yellow. This color do not change in acid, but it turns reddish brown in base. Then next indicator is it is a red cabbage juice. It is purple in color. It turns reddish in acid and greenish yellow in base. The next type of indicator is a phenolphthalein. It is originally colorless. It remains colorless in acid and in base it becomes pink. The next indicator is a methyl orange. Its original color is orange. It turns red in acid and yellow in base. Onion and vanilla, these are the olfactory indicators. There is a no original color, particular color. In acid, there is a no change. They are only used to test base. So smell will vanish, disappear in the presence of base. So that is about the different types of indicators. And then we will study what are acids. So acids are the substances which have sour taste, म्हणजे आंबट चव असते. They turns blue litmus red. They dissolve in water and produce H plus ions. Examples of acids are sulfuric acid having formula H2SO4, acetic acid having formula CH3COOH, nitric acid having formula HNO3. The properties of acids are they have sour taste, turns blue litmus red, then acid solution conducts electricity and it releases H plus ions in aqueous solution. Then types of acids. Acids are divided into two types on the basis of their occurrence. One is a natural acid and other is a mineral acid. First type is natural acid. Natural acids, they are obtained from natural sources. Therefore, they are called as a natural acids. They are also called as organic acids. For example, methanoic acid formula is HCOOH. This is also called as a formic acid, is a common name. Then acetic acid, CH3COOH, oxalic acid, C2H5, C2H4, C2H2O4 is oxalic acid. Then next is mineral acids. Second type of acids are mineral acids. They are prepared from the minerals and therefore they are called as a mineral acids. They are inorganic acids, or they are also called as a man-made acids, or they are also called as a synthetic acids. So all these are the mineral acids. Examples of mineral acids are hydrochloric acid, it is HCl, sulfuric acid is a H2SO4, nitric acid is HNO3, carbonic acid is H2CO3, and phosphoric acid is H3PO4. Now we will study organic acids and their sources, where these organic acids occur in nature. So acetic acid, it is present in vinegar. So remember these sources. This may be asked in examination. Ascorbic acid, it is present in guava, means Peru. Amla means avla. Then citric acid, it is present in lemon, orange, and other citrus fruits. Lactic acid, it is present in curd and sour milk, म्हणजे ताक. Methanoic acid, it is in source is ant sting, म्हणजे मधमाशीची नांगी किंवा तांबड्या मुंगीची नांगी. Nestle sting means this is one of the plant which have a sting like this ant sting. Then oxalic acid, it is present in tomato, and tartaric acid present in tamarind, means chinch. So these are the sources. Remember these names of sources where these acids are present. Then acids are further divided into strong acid and weak acids on the basis of their ionization. So acid, when it is completely ionized in water and produce H plus ion, that is called as a strong acid. Exactly opposite to this, an acid which is partially ionized. So completely ionized and partially ionized. So that is the difference. So acid which is partially ionized in water and produce small amount of hydrogen ion, that is called as a weak acid. And the strong acid is a completely ionized and produce large amount of H plus ion in water, that is called as a strong acid. You have to remember examples of strong acids and examples of weak acids. So examples of strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Examples of weak acids are acetic acid, carbonic acid is H2CO3, that is a concentrated solution of acid diluted by mixing with water. The concentration of hydrogen ion or the hydronium ion, that is H3O plus ion per unit volume, decreases in weak acid. Then bases. So what is a base? Definition of base is bases are bitter in taste, म्हणजे तुरट चव असते. They have soapy touch, turns red litmus blue, and gives hydroxide ion, means OH minus ion in aqueous solution. So examples of these bases are sodium hydroxide, commonly called as a caustic soda, formula is NaOH. Second is calcium hydroxide, it is a CaOH twice. Potassium hydroxide, commonly called as a caustic potash. Remember this difference. Caustic soda is a NaOH, caustic potash is a KOH. Properties of bases we had studied in definition. So they have bitter taste, म्हणजे तुरट चव असते, soapy to touch, turns red litmus blue, and conducts electricity in solution because they contain OH minus ion in their aqueous solution. Then types of bases. This similar to acids, these bases are also divided into two types. One is water soluble and other is a water insoluble. The hydroxide of alkali or alkaline earth metal, which is soluble in water, they are also called as a alkali metals. So they are called as alkali. So bases which are soluble in water, they are called as a alkali. Then sodium hydroxide, magnesium hydroxide, calcium hydroxide, these are the examples of alkali. They are considered as a strong bases. Then next important point of this chapter is to study neutralization reaction. So what is a neutralization reaction? In simple language, this neutralization is a reaction of H plus ion, that is a hydrogen ion of acid, and hydroxide ion of base. They combine, give neutral water molecule. This is called as a neutralization. So neutralization is a reaction of H plus ion of acid and OH minus ion of base give unionized or neutral water molecule is called as a neutralization reaction. We will take particular example of acid and particular example of base. Here HCl is a hydrochloric acid and NaOH is a sodium hydroxide is a base. When this acid react with this base, then H plus ion of HCl react with OH minus ion of sodium hydroxide give H2O, and this NaCl is formed by combination of this Na plus and Cl minus ion. So this gives Na plus ion in aqueous solution, Cl minus ion in aqueous solution. These ions combine give NaCl and side product is water. So this is neutralization reaction and its example. Then strength of acid and bases. The strength of acid and bases, that is based on their pH value, means on the basis of their concentration, that is H plus ion and OH minus ion in base. So acids which complete dissociate, these are called as a strong acids, and the bases which complete dissociate, they are called as a strong bases. Mineral acids, hydrochloric, sulfuric, nitric, these are the strong acids, and the weak acids, these are acetic acid, formic acid. They gives less amount of H plus ion in their solution after dissociation. So this is a pH scale given by scientist Sorensen. The pH range is from 0 to 14. This is divided into two parts. Here it is a 7. So 0 to 7 is an acidic range of pH. 7 to 14 is a basic range of pH. Exactly 7 pH means neutral. So in acidic part, H plus ion concentration increases from 7 to 0 pH, and the decrease in concentration of H plus ion from 7 to 14 pH. So water or neutral solution have pH 7 at this point. For acidic solution, pH is less than 7, means between 0 to 7 in this range. And the basic solution have pH greater than 7, that is in this range 7 to 14. Then pH value shown by different colors of the pH in everyday life. We will study these examples. Before that, we will study this pH strip. So how color change take place? By changing the pH of solution. If the pH of solution is 0, then color is red. pH is 1, it is slightly orange. Then dark yellow when pH is 3. It is light yellow when pH is 3. When pH is 4, light green. Then green color becomes dark. At 7, that is a neutral pH. This is dark green color, and this shades goes on changing till this dark blue color with pH 14. This is called as a pH color strip with their pH value. Now, applications of pH in everyday life. First application is pH in our digestive system. In our digestive system, in stomach, this dilute hydrochloric acid is secreted and it is used for digestion of food. But excess of acid, that is called as indigestion, take place, then acidity creates, and this acidity can be neutralized using antacid tablets. So antacid tablets, they are made up of magnesium hydroxide. This is also called as a milk of magnesia and can be used antacid. Other example is a sodium hydrogen carbonate, that is commonly called as a baking soda, are used to neutralize excess acid. Second example in our day-to-day life is a tooth decay caused by acids. So bacteria present in our mouth converts sugar into acids. When pH of acid form in the mouth it is below 5.5, then tooth decaying starts. The excess acid has to be removed by cleaning the teeth with good quality of toothpaste, and therefore the, there's different kinds of toothpaste, they are alkaline in nature. Third application of pH in everyday life is a soil of pH and the plant growth. Most of the plants have most of the plants have healthy growth when soil has a specific pH, that is the 7. Therefore, these are the compounds with their different pH values. The last part of this chapter is to study salts. So what is a salt? Salt is produced by neutralization reaction between acid and base. So salts are ionic compounds which are produced after neutralization reaction between acid and base. Salts are electrically neutral because they contain equal number of positive and negatively charged ions. The number of salts, there are these there are number of salts, but sodium chloride is the most common type of salt. Sodium chloride is also called as a table salt or the common salt. It is used to enhance the taste of food. Now, acidic, basic, and neutral type of salt. That is the types of salts. First type is a neutral, second is acidic, third is a basic. First, neutral salts. The salts which are produced by the reaction between strong acid and strong base, they are neutral in nature. The pH of these type of salts is a 7, that is a neutral. Therefore, they are called as a neutral salts. For example, sodium chloride and sodium sulfate and potassium chloride. These are the examples. We will study one example of sodium chloride. How it is formed? By reaction between strong acid like HCl and strong base like NaOH. Give NaCl and H2O. Then acidic salts. The salts which are formed after reaction between strong acid and strong base, weak base, they are called as a acidic salt. Acidic salts are formed by the reaction between strong acid and weak base. They have pH less than 7. Examples are ammonium sulfate, ammonium chloride. Here example of ammonium chloride is given. How this salt is formed? By reaction between HCl and NH4OH. Here HCl is a strong acid and NH4OH is a weak base. So by reaction between these two, we get a salt NH4Cl plus H2O. This is a neutralization reaction. This salt is acidic in nature because it is formed from weak acid, sorry, strong acid and weak base. Then basic salts. So these salts are formed by the reaction between weak acid and strong base. Therefore, these salts are called as a basic salts. Examples: sodium carbonate, sodium acetate. One example we will study here is a sodium carbonate having formula Na2CO3. It is formed by the reaction between carbonic acid. It is a weak acid and NaOH is a strong base. So salt formed by reaction between weak acid and strong base is a basic type of salt, sodium carbonate. Then pH value of salt. Neutral salts have pH almost equal to 7. Acidic salt have pH less than 7. Basic salts have pH value more than 7, greater than 7. Remember these values well. Then common salt, sodium chloride. It is also called as a table salt. It is formed by reaction between sodium hydroxide and hydrochloric acid. Both are strong acid and the strong bases. Therefore, this salt is a neutral salt. The pH of this salt is 7 because it is a neutral salt. It is used to enhance the taste of food and it is used for manufacture of many chemicals. Next example of salt is bleaching powder. Formula of bleaching powder is CaOCl2. So bleaching powder is also known as, it is also known as chloride of lime, and it is solid yellowish white in color. Bleaching powder can be easily identified by the strong smell of chlorine. How it is formed, how it is prepared. When slaked lime, that is a calcium hydroxide aqueous solution, when treated with aqueous chlorine gas, that is chlorine gas dissolved in water, when these are mixed, we get bleaching powder, that is CaOCl2, side product is H2O. So aqueous solution of bleaching powder is a basic in nature. So the term meaning bleach means removal of color. Bleaching powder, it is used as a bleaching agent. It works because of oxidation. The chlorine released used for bleaching action of the bleaching powder. Now what are the uses of bleaching powder? Use number one is it is used as a disinfectant. Then it is used for bleaching cotton in textile industry and wood pulp in paper industry. It is used as a oxidizing agent in many industries like textile and paper. Then next salt is a baking soda. It is NaHCO3. Another important product can be obtained as a byproduct, that is a chloralkali process. The chemical name of baking soda is a sodium hydrogen carbonate having formula NaHCO3, also called as a sodium bicarbonate. It is bread soda or also called as a cooking soda or bicarbonate soda, sodium bicarb or bicarb of soda, or simply it is called as a bicarb. So these are the different names. Remember all these names for baking soda. It is prepared by from brine solution. Brine is NaCl solution in water. That is sodium chloride or the common salt solution in water called as a brine solution. When carbon dioxide and ammonia are mixed in brine solution, we get the sodium bicarbonate. This process is called as a Solvay process. Remember this name too. We will consider the reaction. Here NaCl in water is a brine. When mixed with CO2 and NH3, we get NH4Cl, and NaHCO3 is a sodium bicarbonate. This is baking soda. Then properties of this sodium. carbonate, bicarbonate. It is a crystalline solid, fine powder. Then it is amphoteric in nature, sparingly soluble in water means less soluble in water. Thermal decomposition means on heating sodium bicarbonate, it gives the baking soda is heated, it decomposes into carbon dioxide and water. Reaction is 2NHCO3. On heating gives Na2CO3 plus CO2 plus H2O. The sodium carbonate is formed by thermal decomposition of sodium hydrogen carbonate. So this is sodium carbonate. On decomposition gives sodium oxide and carbon dioxide. So this reaction is called as a dehydration reaction because H2O is given out in this reaction. Now we will study uses of baking soda. So baking soda used in cooking to make the food products better soft and the spongy. It is used as a antacid, then used in toothpaste, then cleansing of ornaments of silver म्हणजे चांदीचे दागिने स्वच्छ करण्यासाठी क्लीन करण्यासाठी. So used as a fire extinguisher too. So next is the baking powder. So how this from baking soda baking powder is prepared? A baking powder produces carbon dioxide on heating, therefore called as a, it is used in cooking to make the batter spongy. So how it is prepared? When sodium hydrogen carbonate, that is the baking soda, when heated, it loses carbon dioxide and H2O. The remaining is, so this is the reaction, that is action of heat. And when sodium hydrogen carbonate, that is the baking soda, treated with tartaric acid, it is C4H6OC. It gives the carbon dioxide, water and the sodium tartarate. So Na2C4H4O6, and this is the content of baking soda. Then next example is, second last example is washing soda, commonly called as a sodium carbonate. It is prepared by Solvay process again. So when sodium chloride, carbon dioxide, ammonia and water, they are mixed, it gives sodium bicarbonate. Sodium bicarbonate on heating gives carbon dioxide, H2O and sodium carbonate. It is anhydrous, do not contains water, that is called as a washing soda. So then since this washing soda, it contains the 10 water molecules, hence it is called as a sodium carbonate decahydrate. Decahydrate means 10 water molecules. When it contains the 10 water molecules as a water of crystallization, then it is a crystalline solid, soluble in water. Then it is used for cleaning clothes, then used in making detergent cakes in the to remove permanent hardness of water. If hard water contains the calcium and magnesium ions, this can be removed by using sodium carbonate. It is used in the manufacture of glass and paper. The last part of this chapter is preparation of plaster of Paris. In short, it is called as a POP. It is prepared from this calcium sulfate. When calcium sulfate is heated at 373 Kelvin, it gives calcium sulfate containing half water molecules and 1.5 water molecules are given out. On mixing this with water, the gypsum is obtained and it is called as a plaster of Paris. So this calcium sulfate containing half H2O mixed with 1.5 H2O, we get CaSO4 2H2O, that is the gypsum and commonly called as a plaster of Paris. So that is about this chapter, acid, bases and the salts. Thank you.